About 4 billion years ago, the inner solar system went through a violent phase that scientists can still read in the scars left on the moon. Some researchers nickname this era the solar system's impact catastrophe. When Apollo astronauts brought moon rocks back to Earth in the late 1960s and early 1970s, scientists dating those samples found something strange. A large number of impact-melted rocks all pointed to roughly the same narrow age range, somewhere between about 4.1 and 3.8 billion years ago. That clustering suggested the moon had been struck by an unusually high number of large objects in a relatively short window, a period researchers now call the Late Heavy Bombardment, with some early studies describing it as a sharp lunar cataclysm concentrated around 3.9 billion years ago. The evidence is still visible today. Huge impact basins like Imbrium and Orion Tail, dark plains of ancient lava called Maria that later flooded some of those basins, and countless overlapping craters across the lunar highlands all trace back to this era. Mercury and Mars show similarly heavily cratered terrain from roughly the same time period, suggesting the bombardment wasn't unique to the moon. It likely struck every rocky world in the inner solar system, including early Earth, though our planet's own scars have long since been erased by weather, oceans, and shifting continents, leaving the moon as the clearest surviving record of that violent era. Scientists are still debating exactly why this spike in impacts happened. One leading explanation ties it to changes in the orbits of the giant planets, which could have disturbed asteroids and icy bodies far out in the solar system and sent a wave of them raining inward toward the Sun. Other researchers argue the bombardment wasn't a single sharp event at all, but more of an extended tail from the solar system's chaotic formation, gradually declining rather than spiking. Resolving that debate matters, because it reshapes how astronomers picture the entire early history of the inner planets, not just the moon's cratered face. Crater counting studies on Mercury's heavily pitted surface, imaged in detail by NASA's MESSENGER spacecraft, have added further data points to that ongoing debate in recent years. Understanding this period matters because it overlaps with the earliest known signs of life on Earth. The oldest confirmed microfossils date to roughly 3.5 billion years ago, only a few 100 million years after the bombardment is thought to have tapered off. If the bombardment truly was intense during that window, it raises real questions about how life got started here despite it, or possibly even because impacting comets and asteroids helped deliver some of the water and organic material life needed in the first place. Subscribe for more chapters from the solar system's violent youth.